Now, let's see now what is the addition rule. The addition rule is the rule that let us find the probability that an event A occurs or the event B occurs or both a single outcome of an experiment or procedure. So to apply this rule, it's important to avoid the double counting. So the keyword "or" indicates, that we have an addition. So an important concept you must understand when using this rule, the addition rule, is that what is a compound event? Any event that combines two or more simple events is called compound event. And what are these joint events or events that are mutually exclusive? These joint events are events that are mutually exclusive. These are events that cannot occur at the same time. So, which are examples of a disjoint event? Randomly select a boy and randomly select a girl in a group of pre-K students. Because a student cannot be boy and girl at the same time, for example. So how do you write the addition rule? You say that the probability of A or B will be the probability of A plus the probability of B minus the probability of A and B. Why do you subtract this probability of A and B from the probability of A plus probability of B? Because as we said at the beginning, it's important avoiding double counting. To avoid double counting, you will subtract the probability of A and B, right? Now, important to know that when the events are mutually exclusive events, the probability of A and B will be 0. So when they are disjoint events, the probability of A and B will be 0. So this formula can be reduced to probability of A plus probability of B, right? If the events are disjoint events or mutually exclusive events. When the events are not mutually exclusive, right, then in this case, the probability of A and B is different or 0. So for events that are mutually exclusive, for disjoint events, the probability of A and B is reduced to probability of A. Well, sorry. The probability of A and B is, when it's a disjoint event, is a probability of A or B. Probability of A plus probability of B. Now, what is the probability of A and B? Is the product of the probabilities, the probability of A times the probability of B. So let us give you some examples. A 6-sided dice roll. So find the probability of 3 or 5. So when a 6-sided dice roll, the sample space is made up by the following outcomes: 1, 2, 3, 4, 5, and 6. The total number of outcomes is 6. So they say find the probability of 3 or 5. Only one of the outcomes is 3 and only one of the outcomes is 5. There are no outcomes that are 3 and 5 at the same time, so the probability of 3 and 5 is 0. Right? Because the events are mutually exclusive for our disjoint events. The outcome cannot be both at the same time, cannot be 3 and 5 at the same time. So rolling the die and getting 3 exclude the possibility that rolling the die and getting 5. They are mutually exclusive. Then now we know the probability of 3 and 5 is 0. So we can say the probability of 3 or 5 is equal to the probability of 3 plus the probability of 5. That is the number of events getting 3 over the total number of outcomes plus the number of events getting 5 over the total number of outcomes. We have that there is only one outcome 3 out of 6, and there is only one outcome, 5 out of 6. So this is 1 over 6 plus 1 over 6, which is 2 over 6, which is 1/3. So the probability of 3 and 5 is going to be just 1/3. Look at this other case. They say the table below describes the smoking habits of a group of asthma sufferers. So in the case of men, smoker, no, 544. Suffers asthma. For those that are smoking occasionally, 39. For those that are regular smokers, 70. For those that are heavy smoker, 38. In the case of women, you have 329 that are no smokers, 45 that are occasional smokers, 92 that are regular smoker, 40 that are heavy smoker. If you find the total of all the columns, you get that no smokers are in total 173, occasional 84, regular 162, heavy 78. Now we say if one of the 1,197 people is randomly selected, find the probability of getting a regular or heavy smoker. So probability of heavy or regular. Again, probability of regular and probability of heavy, these two are mutually exclusive. You are either a regular smoker or you are a heavy smoker. So the probability of regular and heavy is 0. So we have a total of 1,197 people that participated in the study. The number of regular smokers, regardless of the sex or gender of the person, is 162. The number of heavy smokers, independently of the gender, is 78. So the events of being a regular smoker or to be a heavy smoker are mutually exclusive or disjoint, because the smoker have to be either regular or heavy, but cannot be both categories at the same time. So since these events are disjoint, there is no overlap between both sets, then the probability of regular smokers and heavy smokers is 0. Using the addition rule formula, we get that the probability of regular smoker or heavy smokers is equal to the probability of regular plus the probability of heavy, which is 162 over 1197 plus 78 over 1,197. It gives you 240 over 1,197, which is equal to 0.201. Like that, we can find more examples. I have multiple examples in this material using cards. I'm trying to find now one example where events don't be this one. This one is a case where the events are not disjoint. They say that a study of consumer smoking habits included 167 people in the 18 to 25 age bracket, 59 of whom smoke, 148 people in the 26 to 32 age bracket, 31 of whom smoke, and 85 people in the 33 to 45 age bracket, where 23 of whom smoke. If one person is randomly selected from this sample, find the probability of getting someone who is age 26 to 32 or smoke. So, and well, they say also find the probability of getting someone who is age 33, 45 or do not smoke or doesn't smoke. Well, the problem is here is clear. Now we have a problem where the events are not mutually exclusive. Why? Because you can be in the bracket from 26 to 32 years old and smoke at the same time. So it's not a contradiction to be in that bracket and to smoke. One event doesn't exclude the occurrence of the other. Exactly like that, are not exclusive, mutually exclusive events just to be in the age 33 to 45 and not to smoke. So when we have to do this, the first we have to do is to organize, our data. So we have from 18 to 25, 59 that smoke. We have then 167 minus 59 that doesn't smoke. We have 31 that smoke. We have 148 minus 31 that doesn't smoke. Because we have in total 148 people that doesn't smoke. This is based on the number of people that are in each bracket. There are 167 people in the first bracket, 148 people in the second bracket, and there are 85 people in the third bracket. So at the end, your table is going to be like in the bracket from 18 to 25, 59 smoke and 108 doesn't smoke, in total 167. 26 to 32 years old bracket, 31 smoke, 117 don't smoke, 148 in total. In the bracket 33 to 45, 23 smoke, 62 don't smoke, and 85 in total. Total number of smokers, 113. Total number of people that doesn't smoke, 287. Total number of people, 400. Now, if we want to find the probability that the person is 26 to 32 and smoke, we know that these are not mutually exclusive because there are, in this case, 31 people that are in the bracket of 26 to 32 and that are a smoker. So you can see this intersection between the bracket of 26 to 32 with the category of smoker gives, that we have 31 people that are in this bracket that they also smoke. So you can say that using the addition rule, the probability of 26 to 32 or to be a smoker is equal to the probability of 26 to 32 plus the probability of a smoker minus the probability of 26 to 32 and a smoker. So how many people are 26 to 32? 148 in total, right? So probability of 26 to 32, there are 148. Probability of a smoke is 113 over 400 because we have 113 people that smoke out of 400 minus the probability of people that are 26 to 32 and they also smoke. And these are these 31 people we have over here. So we say that this is 148 over 400 plus 113 over 400 minus 31 over 400. At the end, you get 0.575. So this is then the probability of people that are in the bracket 26 to 32 and are also a smoker. In this case, if you don't subtract, the probability of people that are in the bracket and smoke at the same time, you will be counting twice the same group of people. You will be counting these 31 people twice because you include these 31 people when you say that there are 148 people in the bracket from 26 to 32 that include these 31 people. But you also include the 31 people when you say that there are 113 smokers. So you included the 31 here, and you later include it again when you say that they smoke. So you see that's why you need to subtract once these people, otherwise you will count them twice.